is another Higgs video. This is my research on it. So this is top quarks, elementary particles, standard model, Higgs boson, fundamental interactions. This must be a research. So there's the standard model with the Higgs boson on it. I better read this. Okay, so these are the quarks, and these are your leptons over here. And this is fermions and bosons. Okay, so it says up, charm, top, down, strange, bottom. Electron, neutrino, muon, neutrino, ta, neutrino, electron, muon, ta. The bosons are photon, Z boson, W boson, and G gluon. Those are force carriers, and then there's the Higgs boson that we've just discovered in June 2012. So August 16th was when I was working on the WOW data, and this is September 29th, and I guess I forgot to put cross-reference at the top, put the word WOW. I should add the word WOW up there. Okay, so cross-reference WOW data, line 18A, 3W4, uranium neutrino split Z bosons, weak atomic 5G UFO WOW SETI. Looking at the standard model in the diagram, T top quark sits beside Y photon, 2/3, 1/2 the spin in the top quark, Google spin top quark. So this is what came up with this diagram here. Okay, showing all the different things we have going on there. A collision event involving top quarks to top antitop quark event. August 16, my thoughts. Looking at the diagram of the collision event, the Higgs boson is the red line of circles in the middle with P and line over P. That's the Higgs boson signal right here, right in the middle. The top quark, also known, and this is a quote from Wiki, as the T quark, symbol T or truth quark, is an elementary particle and a fundamental constituent of matter. Like all quarks, the top quark is an elementary fermion with spin of 1/2 and experiences all four fundamental interactions: gravitation, electromagnetism, weak interactions, and strong interactions. It has an electric charge of 2/3 E and is the most massive of all observed elementary particles. It has a mass of 172.9 plus minus 1.5 GeV to C squared, which is about the same mass as an atom of tungsten. The antiparticle of the top quark is the top antiquark, symbol T, sometimes called antitop quark or simply antitop, which differs from it only in that some of its properties have equal magnitude but opposite sign. The top quark interacts primarily by the strong interaction, but can only decay through the weak force. It almost exclusively decays to a W boson and a bottom quark, but it can also sometimes decay into a strange quark, and on the rarest occasions into a down quark. The standard model predicts its mean lifetime to be roughly 5 times 10 to the 25 s. This is about 20 times shorter than the timescale for strong interactions, and therefore it does not form hadrons, giving physics a unique opportunity to study a bare quark. All other quarks hadronize, meaning they can only be found in hadrons. Because it is so massive, the properties of the top quark allow predictions to be made of the mass of the Higgs boson under certain extensions of the standard model. See mass and coupling to the Higgs boson below, as much as is extensively studied as a means to discriminate between competing theories. Fundamental interactions, quote Wiki. The four known fundamental interactions are electromagnetism, strong interaction, strong nuclear force, weak interaction, weak nuclear force, and gravitation. All are non-contact forces. With the possible exception of gravitation, these interactions can usually be described in a set of calculational approximation methods known as perturbation theory as being mediated by the exchange of God's bosons between particles. However, there are situations where perturbation theory does not adequately describe the observed phenomena, such as bound states and solitons. Google elementary particles for a diagram. Keyword from the reading data is Tachyon condensation. So here's the elementary particles diagram, and it shows the force carriers are gluons, W, Z bosons, photons, gravitons, strong, weak, electromagnetism, gravity, quantum chromodynamics, quantum electrodynamics, and quantum gravity, electroweak theory, grand unifield theory, theory of everything, and then it says forces. On this side we have matter, quarks, leptons, quark, lepton, complementarity, hadrons, mesons, baryons, nuclei, atoms, and molecules, composite particles. Okay, Thanks for watching, and we'll go on to another Higgs video.